Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video on stem and leaf plots. So stem and leaf plots are just convenient ways to display data like this. So this is just data I have of heart rate from students who play sport and do not play sport. We're going to display both of these data sets in the same stem and leaf plot. So what we do is we start with a stem in the middle. This is the number of tens. So all of these scores go from the 40s to the 90s. So we go 4, that's 40s, 50s, 60s, 70s, 80s, and 90s. So we're actually going to make what's called a back-to-back stem and leaf plot. So one side we have the first set of data, those who play sport, and then those who do not play sport on the other side. So we'll start by putting this into our stem and leaf plot. So we put a 9 here. This represents 49. It's in the 40s and the leaf is 9, stem 4, leaf 9 means 49. So then the next one, 64, goes there. Then we go 72, 75, 78, and 78. So we have lower scores closest to the stem. And then, of course, we have 83 and 90. So let's do the same for the do not play sports category. So we have 55, 74, 76, 83, 88, 89, 92, 96, and 2 lots of 98. So just like the grouped data that we saw in the previous video, stem and leaf plots group the data. They group it in tens. But what this has an advantage over grouped histograms or grouped frequency tables is that we have all the data points. So we could calculate the mean and median of these two groups really easily. So there isn't really an easy way to do it. To calculate the mean, we just have to add up the scores and divide by how many. Now, the biggest mistake people make when they're doing this is they think this score means 9, this means 4. You don't go 9 plus 4 plus 2, etc. You go 49 plus 64 plus 72, and so on. So the mean here was 589. That's the sum of all scores divided by how many there are, which gave us 73.625. Now, for the group who does not play sport, if you add up all the scores, you get 849. There are 10 in total, so the mean is 84.9. Now, if we're finding the median, we can use the n plus 1 on 2 formula that we learned in a previous lesson. Another way people might like to do it is cross out the scores. So we want to find the middle score. So we can cross out the two extremes, then the next lowest and next highest, then the next highest, next lowest, and we have two middle scores here, 75 and 78. The median isn't 8 plus 5 over 2. We'll add up the two middle scores, which are 78 and 75, add them up and divide by 2, and you get 76.5. So doing similarly for the other group, we can cross out the highest and lowest, and then we can cross out second lowest and second highest, and keep doing this until we get the two middle scores, 83 and 88. So the median of this group is 83 plus 88 divided by 2, giving us 85.5. So this has allowed us to compare data sets. We can see from the mean and the median of both groups in the stem and leaf plot, clearly those that don't play sport have a higher heart rate. So that's what stem and leaf plots and statistics are good for, comparing data sets. So I'm just going to put this does not play sport group in a grouped frequency table, just to show you. So if I were going to draw a grouped frequency table, we have all the scores in the 40s, all the scores in the 50s. Remember the way we read something like this? X is between 60 and 70. It includes 60, but not 70. So frequencies, there were none in the 40s, 1 in the 50s, 2 in the 70s, and then 3, and then 4. So remember, the CF column means cumulative frequency, so there were 0 scores that were less than 50, there's 1 score that is less than 60, and then there's still 1 score less than 70, and then we go 1 plus 2 gives you 3, 3 plus 3 gives you 6, 6 plus 4 gives you 10. But the thing is, if I put it in a grouped frequency table, I lose the individual data values. So we can't see from this what the individual data values are. So if we wanted to calculate the mean and median just from this table, we would have to estimate, as we did in the previous lesson. So stem and leaf plots are almost like histograms on their side, so we can tell the skewness very easily. So for the does not play sport, you can see that there are many more scores closer to the maximum. So the data here is negatively skewed. Data scores clustered around the maximum, in other words, more high scores, that's negatively skewed. Now, as for the play sport group, you could sort of argue either. You could sort of argue the highest frequency of scores are in the middle, so you'd probably say this is symmetrical. Now, it doesn't have to be exactly symmetrical, but it's kind of close enough. So you could also make an argument, if you wanted to, that this is on the higher end, so it's negatively skewed, but it's probably symmetrical. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.